Hello friends, let us start with stable systems and unstable system. In this video, we will understand what is meant by stable systems and unstable systems, and along with that, when outputs are expressed in terms of input, then looking at that relation, we will try to identify which systems are stable, which systems are unstable. Let us begin. So to start with numericals, first of all understand the definition of stable as well as unstable system. Stable system are those system which produces bounded output for bounded input. So this term is very important. For bounded input, a particular system, when it generates bounded output, then it is called as stable system. In fact, therefore stable systems are also called as BIBO systems. BIBO stands for bounded input, bounded output. So for bounded input, when it is producing bounded output, it is called as a stable system, whereas unstable systems are those systems which are producing unbounded output. So pay attention, here it was bounded output for stable systems. Now unstable systems are those systems which are producing unbounded output in response to applied bounded input. So let us understand what is exactly meant by bounded and unbounded, whether it is input or output. Let us understand what is meant by a bounded characteristic and unbounded characteristic. So I have taken some examples in the next slide. So these are some examples. Looking at those characteristics, I'll now teach you how to identify it is bounded or unbounded. See, this bounded refers to a word called as a boundary. So you don't have to cross the boundary, meaning that you have to keep amplitudes of the signal inside the boundary, that is finite one. Once amplitude becomes infinite, it means you have now crossed the boundary and now it becomes unbounded. For example, look at x1 of t. It is a unit step signal, right? So even though it is starting with 0 and again it is never ending signal up to t equal to infinity, it is going to remain 1. So my question is, anywhere you feel that u of t amplitude is becoming infinity? No. Of course it is infinite duration signal, but that duration is not important. What is important is amplitude everywhere. So as you can see, for t greater than 0 amplitude is 1, and for t less than 0 amplitude is 0. So amplitude will have only two possibilities, either 0 or 1, and of course at t equal to 0 by Gibbs phenomena we say it is half. But the point is, everywhere amplitude is finite, and therefore such signal is called as a bounded signal. So what we are going to see is bounded versus unbounded. So example number 1, that is x1 of t, is a bounded signal category. Let us look at x2 of t. You can see that x2 of t is simply a sinusoidal signal where the maximum amplitude is +2 and the minimum amplitude is -2. And as you can see, a sine wave is varying its amplitude between +2 and -2. Am I right? So for infinity time, it is going to remain sinusoidal. Anywhere, even though t tends to infinity, the amplitude would be somewhere in between +2 to -2. So amplitude is going to remain finite, and therefore this is also comes in bounded signal category, right? Let's look at x3 of t. If you look at signal, actually this is a ramp function. So this is a ramp function, am I right? And the amplitude is growing in nature. So at some time, amplitude will reach to infinity, right? Since at some time it might happen that amplitude is approaching towards infinity, such signal is called as unbounded signal. So anywhere amplitude goes infinity, it is 100% unbounded signal. Look at x4 of t here. You can see that it is a simple gate pulse starting at t equal to 0, ending at t equal to 2. So it is a finite duration signal, okay? Unlike x1 of t. x1 of t was infinite duration signal. x4 of t here, it is a finite duration signal. It is a finite duration signal, but that duration is not important. What is important is an amplitude. So as you can see, the maximum amplitude is 3 here. So it is a bounded signal category. Finally, look at x5 of t. If you observe carefully, it is unit impulse signal, right? So what do you think? The unit impulse signal comes in bounded signal category or unbounded signal category? So some student says, sir, since 1 is written here, since it is a unit impulse, therefore it is a bounded signal category. Then let me tell you that 1 is not a magnitude, or that 1 is not an amplitude. In fact, L of t is always equal to infinity at t equal to 0, and it is equal to 0 when t is not equal to 0. What is written 1 over here? It is basically the area of that unit impulse signal. Am I right? So of course area is finite, but we are not talking about area. It is what we talk about an amplitude. So our concern is regarding an amplitude. Amplitude is tending to infinity when t equal to 0, and therefore such signals are called as unbounded signal. Therefore x phi of t is called as unbounded signal. So I'm now sure you are crystal clear about what is meant by bounded signal and what is meant by unbounded signal. So let's just go back to the definition and let's try to understand the definitions of stable systems versus unstable system. Now you will understand it better. Stable systems are those systems which are producing bounded output for bounded input. For example, you are having some system. So now we are less concerned what is inside the system. Let's say you are applying some input. By definition, input must be bounded. So some, let's say u of t is applied here. Okay, and in response to that you're getting some output like this. So if you see, nature of input is bounded and nature of output is also bounded. So for bounded input, every time if you're getting bounded output, then we are happy about it and they are called as a stable system. Am I right? So what is meant by unstable system then? See, unstable systems are those systems for which, let's say, some bounded input is applied, but then it is producing unbounded signal. Okay, because this is an example of unbounded signal. This is a ramp function where amplitude is increasing with respect to time. So at some point this is tending to infinity, and therefore output is unbounded category type. Input is bounded category type, but then it is a rule that input must be bounded. I mean, you cannot check stability of the system by applying unbounded input. I mean, you cannot apply unbounded input here, because applying bounded input only will cause system to keep output also bounded. But if you apply input only unbounded, then output may be unbounded in nature. In that case, you cannot decide whether system is stable or unstable, right? So the rule is input must be bounded. So stability of the system is checked only by applying bounded input and then observing output whether it is bounded or unbounded. Now we can start with the examples. So here set of examples are given. Y of t is equal to x square of t. So we'll start with first example first. So what I'll do, I'll write x of t versus y of t. Let's say if x of t is 1, y of t will be square of x of t, that is 1. Let's say if x of t is 2, then y of t will become 4. If x of t is 3, y of t will become 9. Like that. Let's say if x of t is 15, output is 225. Up to infinity if I go, then I'll get infinity. Now infinity is unbounded, but then input is also unbounded. But we are not allowed to apply infinity input, meaning that for all set of finite inputs, you are getting finite outputs. To be very precise, in terms of signals and system language, finite input means those inputs which are bounded in nature, and finite outputs are those outputs which are bounded in nature. So for bounded input, you are getting bounded output. In fact, when I say y of t is equal to x square of t, for every finite value of x of t, square of finite value is always some finite value only. Am I right? Therefore, by observation only, one can say that it is 100% a stable system. Is that right? Let's say I'm taking one more extra example here. Let's say y of t is equal to e to the power x of t. Again, I'm having some x of t value versus some y of t. Let's say if x of t is 1, y of t will be e to the power 1. Let's say if x of t is 2, it will be e to the power 2. Let's say if I take x of t 100, it would be e to the power 100. Let me tell you, if you calculate them, all of them will be finite value. Of course, e to the power 100 value will be so high value in numerical sense, but definitely it is not infinite. So for bounded input, of course you are getting bounded output only. Is that right? Only if you apply x of t as infinity, which you are not allowed to apply because the definition says only for bounded input you should check stability of the system. So infinity will only give you output as infinity. Otherwise, it is not possible to have output as unbounded one. Am I right? Therefore, this case would be invalid for us, and it is a common sense that e to the power finite value will be always a finite value. Is that right? Therefore, this is also a stable system, right? Let's go for the next example. So, third example is y of t is equal to integration from minus infinity to t x of tau d tau. So, this is a perfect integrator equation. You know that this input you have to always take a bounded one. Is that right? In that case, suppose input is u of t. You know that u of t is the perfect example of bounded signal. And if you take integration of u of t, right, then this is always giving you what? A ramp function, and ramp function is this signal. So as you can see, output is ramp function whose amplitude is tending to infinity. Therefore, it is unbounded output. So now this is very important conclusion for us. Input was bounded type for which you are getting unbounded output. Therefore, I can declare that this system equation is belonging to unstable system. Is that right? Now, for example, I'm just trying to modify this given equation. Let's say y of t is an integration of x of tau d tau. But this time, let's say they have taken integration from 0 to t only. So lower limit I have changed from minus infinity. Okay, so it is just a 0 to t. Again, if I take 0 to t, u of tau d tau, again unit step signal only I have taken. We know that after 0, u of tau value is always 1. Therefore, the value of u of tau is 1. So it is just an integration from 0 to t, 1 d tau. And what is integration of 1? Of course, it is t. So answer is t. And if you plot t, again it is a ramp signal with slope value equal to 1. So again this is unbounded only. So integrator system will be always unstable system only, right? So let's start with the next example. We have y of t equal to sine of t dot x of t. Now let x of t is 1, then y of t will be sine of t. If x of t is, let's say, 10, output will be 10 times sine of t. If, let's say, input is 100, output will be 100 sine of t. Let's see, if it is sine of t, it would be this kind of signal where amplitude is +1 or -1, or amplitude will lie between +1 to -1. When I say 10 sine t, it will be sine signal only, but having now higher amplitude, that is between +10 and -10. So amplitude will lie between -10 to +10. Or when I'm talking about 100 sine t, of course amplitude will increase this time, but then it will be in between -100 to +100. So as you can see that even though I'm getting different sine signals with different amplitudes, we know that every sinusoidal signal is a bounded signal category. Therefore, for bounded input, you are getting bounded output, and therefore it comes under a stable signal category. So this is also pretty common sense. Like you don't have to really go through this whole procedure. Y of t. See, sinusoidal signal, that is sine t, is by default a bounded signal category. We know that we check whether systems are stable or unstable only for bounded inputs. So x of t will be another signal which is also bounded. So bounded into bounded will always give you product as bounded only. Therefore, system would be by default stable, right? So now only one example is left where y of t will be equal to e to the power t x of t. Let us solve this problem. So let us start with this example. So y of t is equal to e to the power t x of t. Let us assume x of t, this is y of t here. Let's say x of t is 1, then y of t will be simply e to the power t. Let's try to plot e to the power t. If you plot e to the power t, it is a positive exponential curve. As you can see, this amplitude is going up to infinity, am I right? Or amplitude is approaching to infinity because it is a positive exponential curve, and a positive exponential curve looks like this. 100% this is unbounded category output. This unbounded output. So for x of t equal to 1, which was bounded input, you are getting what result? Unbounded output. So when bounded input produces unbounded output, such system is called as unstable system. So this was an example of unstable system. So whenever for a particular system, when you are trying to identify whether it is stable or unstable, you just try to make that system as unstable, but not at the cost of applying unbounded input. The rule is you should apply bounded input in such a way, or variety of bounded input in such a way, that you are trying to unstabilize the system. But at any cost, if it doesn't get unstabilized, then the respective system is called as a stable system, else it is unstable system. Thank you.